Hi, today we're going to make a electronic configuration calculator, and we're going to try to search the electronic configuration of different type of elements with the atomic number. Okay, so for start I want to make an integer with an input, because you know what, with the input we can communicate with the real world, and later on we put this in an integer. Because like if we put, like, I don't know, a string or other thing that is in an integer, basically the program will make a collapse, and this would prevent, well, that people doesn't put like any other weird thing and only like put the number. Later on we make a string without any character here, like only an empty string, and later on we make a list with the subshells with with 1s to 7p, because that's like what electronic configuration, like its form has. Like I would say like the electronic configuration is made by these sub levels, like, and they are going from 1s to 7p. And we make this list because basically with this list we're going to make a for loop right there, and when we write, like, I don't know, when we run for start the program, we are going to basically use this like subshells of this list to basically put it in the program right there, like here. Okay, so later on we define a function that is calculator lowercase chem. Well, it will be in English chem, but like I'm a Spanish guy, so I put chem. But well, and we put this like it's an s from string, and we put a global variable, in this case mathsco. What I put mathsco, I don't know. Like if it's like I put this because it's like sound like the same with maths coefficient. But well, I put this with this name because because it sounds like maths coefficient, but maths coefficient is for me long, so I put mathsco. Well, you know that, well, in the strings we got the part 0 and we got the part 1, and basically this is the part 0, the number, but we need the subshell of the part 1, that is like the letter of this complete string. So basically we put the part with the letter like this, and basically we put like if s1, if the part 1 of the string, like is this one, is the if the subshell 1 of the string, this one is the letter s, maths coefficient will be 2. In case it will be p, maths coefficient will be 6, and in case it will be f, maths coefficient will be 10, and in case it's d, maths coefficient will be 14. Later on we'll make this for loop with this variable x in the range of the length of all this list. Why? Because we want to like make sure that you don't put a very big number of element that like doesn't exist in the, well, in the periodic table. So like I put this in this range with the length of the sub levels of the electronic configuration. Later on we'll make this function analyzing that if the sub level is S, if the sub level is P, if the sub level is F. Well, if the subshell indeed, if the subshell one is S, if the subshell one is P, if the subshell one is F, they will put this match coefficient, and later on we make this. If the element is 0, we're going to break this for loop. Why? Well, very simple. Because basically, if we put 0 in the atomic number, your element basically doesn't exist, because there aren't elements that have like 0 of his atomic number, of its atomic number. And basically this will break the for loop, and later on we put this else if, basically saying that if the element is higher than the match coefficient, we are going to make the electronic configuration plus the sub level of X plus the strength of match scope plus space. Why? Basically, the thing that we're doing here is that we put this empty space. Later on, we sum this with the sub level of X with the range, like an example. If it's the second, it will be plus 2 is, and with the string of match scope, because if it's S, basically the match scope will be 2. So we put like this: 1s2, 2s2, with the string of match scope and with a space to the other elements. Later on, we basically put this element, and we make a difference here with the match coefficient. Why? Because we need to make like the electronic configuration have its own order. And if we put here 1s2, the element will be make a difference with the number 2. Well, so continuing with this else if the element is bigger than the match coefficient, we are going to put the electronic configuration plus the sublevel of X, and this is the important part, with the string of the element. Why? Because basically, if the element is like is like less from the match coefficient, this will make that the element will break out. An example: if we are in the letter P and the element is lower than the match coefficient of X, this will end this for loop, making that the empty space basically doesn't exist, and like putting things in the empty space of the electronic configuration. And later on we make the sum with the string of the element, because we are going to ensure that at the end the element, well, the number of the element, because like it's not like the element, the atomic number of the element, making many differentiations from the match coefficient, will make a number that is, well, lower than the match coefficient, and this will basically end all the electronic configuration. Later on we print the element to know how the element is lowering, and we print the electronic configuration. So what? There's an error here, I don't know why. Name error, config. Yeah, well, if I put like, I don't know, 20, basically the program will start to run, and they will make the difference between like 20 minus 2, it will be 18, 1 is 2, 18 minus 2, it will be 16. Well, that will be 2s2, and later on we make the difference between the 60 and the 6 to make it 10, and we continue to make the electronic configuration of the elements, with the atomic number. So that will be goodbye, and have a good day, a good evening, a good night. See you on